And we're very happy to be here and to officially premiere the product. So Robert, the floor is yours. And just as a reminder, we will be recording from this point on.
Okay, great, thank you. So you've heard of us talking about the SiteLog manager on our Monday session of at the IC of what it is, talking about the metadata that the users have and we're saving, and how important it is to the community. So we've talked about the SLM SiteLog manager, but to the many people that know, excellent, and to the others, well, let me just introduce to you to what the SLM is, what the SiteLog manager is, where it has been, and we'll talk about where it is right now and where we want it to go and why we want to go where we want to go. So with that, well, so what's the SiteLog manager? It was a software that was written a long time ago, an ecosystem of the sort that was developed to assist the station operators with giving them a nice GUI at the time to update their ASCII site logs, the station metadata for any component of the site logs. So the system was developed, and it gave the option for the station operators at whatever time of day that is convenient to them to just log into the system and just either upload the ASCII site log to them, or just or to update a specific component of the site log. For example, like a new update to the receiver. I'll show some screenshots later on as to what I'm talking about. So this SLM, it's automatically, as somebody if they were to upload the site log, it parts through the ASCII site log. It detects any errors, if there was any errors with it, and it prompted the user to correct the errors all in real time at the time without having the involvement of the network coordinator's intervention. So, and this system also enables the users to save partial information. So if some information was available to them, they can fill it in, hit the save button, but not necessarily submit for approval. And then later on in the next day or two, once the information became available to them, then they can log back into the system and add the component that was needed and then hit submit. So, and upon succession, all this metadata is saved in an SQL database. So this gave the users, the station operators, the ability for the Central Bureau to house all the site logs and for them not to maintain a copy of the site logs in their own database and then having to modify and then to send it. So we would keep it and give the ability for users to just upload whatever component they need. And because the back end of this was an SQL database, it is the use of generating various multiple products, for example, like the IGS Synix file, or the network, the IGS network JSON file, or the receiver and JSON file. So for users to just download it, and it's a program friendly, just import, and if you're using Python, it's very native to use it. And also giving us the ability to produce high resolution images for the entire network and as seen fit. So moving on, an example of a site log of what we're talking about of the metadata. For example, this I took an example of out of the ABPO in Madagascar. And you can see, for example, this particular station went through 9 iterations of a receiver. We see at 3.9 at having a septentrion. And it's not just the updates to, for example, the receiver was changed completely, but for example, the firmware was changed. For this particular station in 2017, the receiver remained the same, but the firmware versions kept on changing, kept on updating, and this gave the capability of tracking more constellations. And similarly, on the right side of your screen, you can see for the antenna types, when the station started in 2007, I believe it was, It had this one particular antenna, the hashtag with the dome installed. However, in 2018, the alignment you see at the bottom, the antenna was aligned to the true north, which constituted for a new section. Which gives a new entry in the SINEX file and the ability for the station users to understand what changed within the antenna. So this information, everything is kept in the database, and we are able to render everything out for any component that we need and for whatever we want. And the site logs are all generated at the URL you see on the bottom left for files.igs.org. So we're talking about all of this. Well, what are the usages of it? Who's using it? What's using it? So we have 148 registered agencies that are using the SiteLog Manager. And the SiteLog Manager, while we see we have over 750 stations in there, with only 500 plus stations on as an active IGS network. But we also have former stations for old stations that have since gone away, and we also have the proposed stations that we're also saving in the database. Some of the users that you see, they're from a direct IP for which there's no DNS register to it, so we don't know exactly what agency that they're registered with. We see some nonprofit organizations, the US military for the station operator that are accessing it, and we can see they're using Androids or Windows, Mac, with some consistent usage of how the users are coming in and what software they're using to access it. And you can see most of the users are using Google Chrome to access this station, the SiteLog. So we're talking about what it is. So just to give you a snapshot of things, at URL slm.igs.org, when you go there, you see a login page that users get prompted to log in. All the users are authorized by the network coordinator. And when they do have an account, when they're signed in for each agency, they're mapped to a list of stations or either one-to-one. And we saw from Markus's presentation on Monday that there are quite a bit of agencies that have just one station registered for the IGS network, but there we also have other agencies that have multiple stations that are in the IGS network. So when the user logs in, what they get to see is a screen similar to this. I'm currently logged in here as an administrator, so I get to see all the stations and some additional menu options. So on the left-hand side, when the station operator logs in, they see all the stations that are listed that pertains to their network. And then if a user, whatever they want to change, they select a particular station. Like here, I just selected ABPO, and they select what area, what component, what header they want to update. And this would be the receiver. So they would click on the receiver. And then on the right-hand side, it would prompt them that this is currently what you're seeing from the database that's pulled in section 3.9. And if they want to add a new particular, just new section for this, then they have the add new section. They just click on it, and there's a web GUI that just guides them through. Or if they want, they have the option of just uploading an entire site log, and the system will take it, parse it, and add whatever sections that was modified to that. One of the other nice things that this tool also tells the network operator and also the station operator is whether there was any errors or anything that requires attention for them. So for example, all the reds here, this top 4 is the test stations that on the next slide, I'll talk about some of the issues that we've had with on why they exist here. So you can see on some of the stations, there's about 13 errors to them. Some errors that might have been things that we want to be clarified, but maybe at this time that we just don't know, or we just never knew because it could be the station was so long ago that the records weren't kept for whatever reason. Things that have been deemed as required fields that we want to know and information is not available will be tagged as an error. And in the amber color, we have the preferred stations, that things that we would like to know, but it is not mandatory. And if it is left empty, then we tag it to say, hey, this is an area that is rather optional. We would like to know, and if it is available, then please give us the information. And in the yellow color is areas that were submitted or that were modified. Excuse me. The yellows are sections that have been modified, but not yet submitted for evaluation by the network coordinator. So this system, when it was built, it was built a while back, and it did the work. And then, as with any software engineering lifecycle, the software has to be kept maintained and updated. And through time, this rendered us with some of the issues that we've had over the time. For example, this software was built for PHP 5.0. And as we know, the 5.0 end of life came 2019 January. And we, since then, the systems have gone through much updates, enhancements, and we have went into the to the AWS cloud with the newer systems, newer updated, and PHP 5 no longer is supported. So we have to install a later version of a PHP. Well, the software was written back then, and some the functions or the calls or the procedures of how a PHP 5 is built on was no longer available on 7. Some areas were being deprecated, and it's rendered quite a bit of the core fundamental components of the SLM useless. It just was not working, and everything just, it seemed everything in the background was quite a bit broken simply by just that one move. The original developer had since moved on and was no longer available. And so we went in and we said, okay, some core functions, we have to really just patch this up and just get it to work. We patched it up, we got everything to some of the components, some of the core components, we got it to work. And upon further analysis of the software, we saw that there's quite a bit that needs to be modified and needs to be recorded, that was just rendering just extremely inefficient to just patch all of them. So that's where we said, okay, it's better to just write a new with utilizing today's technology and today's methodology and with the systems that we have today for the new SLM. The existing SLM of this legacy that we have right now, it has no support for interoperability. We cannot communicate with having a system foundation built that for it to automatically communicate with other network agencies like the Canadian agency or GA or Europe to just have, when we have a station that we have shared across the networks, in case if a station operator goes to modify a station, for example, at GA, and if this station is part of the IGS network, the system will be capable of just updating it automatically without the user having to go and update their station metadata information for 2, 3, 4 network agencies if the station is contributing to that. There's no support for the GeodesyML for this existing software or JSON to upload or download, and no command line APIs. So with these issues, we said, okay, it's time to move on and build something new. And so we did. And at this point, for introducing the SLM 2.0, I'll pass the floor to Brian, and he can guide us through this, and then we'll show a little bit of a demo for a live demo of what it actually does. Go ahead, Brian.
Hello, my name's Brian Kohan. I'm been developing this new SLM 2.0 now for the past few months. So the primary goal with SLM 2.0 is really the same as the SLM 1.0, and that is to maximize the reliability, accuracy, and searchability of our station metadata. And you know, given that a long amount of time has passed since the first SLM was developed, there are a lot of advances in web development and open source tooling we can leverage in better ways to help us hit that goal. So, a few of those ways is, moderation just needs to be as easy as possible, and reviewing changes needs to be as easy as possible. Perhaps sort of the biggest value add of new open source web technologies is how they help you automate more tasks. So automation is key to increasing, those three characteristics of metadata, and that is automation both in terms of validation and doing more rich validation, but also just using the system. There are ways, if you can use a program to update certain data, it's going to be better than human in the loop systems for avoiding all the errors that humans typically introduce. And then structured data. So the previous SLM, it's based off this ASCII SiteLog format. So under the covers on the back end, a lot of these fields are actually plain text ASCII. And so if you want to search on, a field that should be an integer value, it's not going to work quite right. So we have a task of slowly migrating over time into more sort of a structured data format. And that both means strongly typed metadata, as well as self-validating interchange formats like GeodesyML, which Markus can talk about later. And then more easy to use renderings like JSON. XML is great in the sense that it is self-validating. You can have schemas for it, and so it's superior as an interchange format. But a lot of times, if people are just writing a quick Python program, they're going to want to use something more like JSON. And then broad adoption. We are going to make the SLM 2.0 open source. It will be on GitHub. And since we've leveraged a bunch of mature open source technologies that I'll show next, it is very extendable. So if another organization wants to use it to manage their own SiteLog meta information, they should be able to pull it down and do so. Go next, Robert. So what is it built on? Under the hood, it's Python. So we've moved from PHP to Python, and it's using the Django web framework, which has been around for about 17 years now. It's supported by an open source development foundation that has several paid staff. So it's pretty robust technology that's not going anywhere. It's one of the more superior web frameworks out there. Certainly, in my opinion, probably the best open source web framework. And we're using a Django REST plugin on top of that to help sort of generate structured APIs from our data models. This in under the covers, this is all served on a relational database. Right now, our operational system is going to use MySQL, but you could use something else like Postgre or any relational database that Django supports, which is most of the big ones. And then we're using Python package management build tooling called Poetry, which is quite robust. So the goal is, and this is how we're going to manage it at IGS, is when we want to update our operational deployment, we're just going to pip install the latest version of it. So anyone else who wants to use it should be able to do the same. And this will be on GitHub. That's linked there. It's not there yet, but it'll be up soon. And so the important thing to note about the backend is that all the data is stored in a relational database. It's not stored in GeodesyML, JSON, or ASCII log format. The gold source is a relational database that stores time series edit information. So we have history going back as long as we want to keep it to edits to the site log. And then the format that the logs are viewed in, whether that be GeodesyML, JSON, or ASCII, that you consider that a view of the data. So those are rendered on demand. And this allows us to do arbitrarily complex validation. Like XML schema is self-validating, but there are some limitations to how much validation it can do. Our system, since it's built on a relational database, can do arbitrarily complex validation routines. And the nice thing about most web frameworks, and Django in particular, is, since this is all stored in a SQL database, Django provides this Python interface on top of that. So at no point in our development have we had to write any SQL, which is a real boon to making it more maintainable going on in the future. All right, next, Robert. So let's skip this slide, keep moving. Should be one more. So where we are right now, phase one, the goal is to get to operational deployment. We're nearly there. We just got to do some testing and wrap out one or two more pieces of functionality, and then we'll go live with that phase. We'll have a demo up before we transition to the new SLM that we'll send an email out about, that folks can play around with. And then once we're in operation with SLM2, we'll move to a phase two and add some more goodies that we'd really like to have, which is full support for GeodesyML, JSON, and make our APIs more rich. And with that, I think I'm going to take over and go through a quick demo.
Yep.
All right, so I'm going to log into my admin account here. So you'll see the layout is similar to the old SiteLog manager. It's just a little more modern looking. You've got site navigation over here to the left, and you can search for sites this way. Since this is an admin account, I see all sites. There are about 750, I think. Yeah, 749 in here right now. If you're logged into a normal user account, you'll just see sites that you have edit access to, which is mostly handled through your relationship to an agency. So just to give you an idea of what it's like to edit here. So again, similar layout to the old SiteLog manager. We've got all the forms here on the left. And the color codes here are status indicators. So green would mean that the most recent version of the SiteLog in the database is published and is viewable by the world. But if we want to update it, let's add a receiver. Just give it some values here. Don't have to be right. We'll see that we now have some unpublished changes. So these colors have changed to yellow, and we have a validation, a moderation action, one of our automated triggers. And the validation is, since this is designed to be used by whoever wants to use it, it's very configurable. So these are configured per deployment, the set of validation rules that you want to activate on data. And there are three main levels of validation flags. So there's the highest level. Let's say if I just put in some garbage into one of these fields, it won't even let me input this in the database. It just rejected it outright. There's this level of validation flag, which is we're not going to let you publish this until you fill this field in. So let's give it something to make it happy. And then the last level of validation flag is you can still publish it, but the flag is there because we would like it would be better if it were updated. And admins have the ability to add any flags to any part of the data that they want manually. So we've made it happy. Since we have now information going back in time, all the edit histories, you can view that over here in the site logs. So this is the most recent one. If we look at review, this is showing us the difference between this site log and the what's published, what's viewable by the world. So we can see we added this receiver. You can also see what edits were made specifically. Like here, I deleted something a little bit ago. So that was the edit that was made then. And you can compare any diff to any. So if I wanted to say, I want to see the difference between the head version and what was published as of, went back to, this was the last time it was published there. So you can see there have been quite a few. I've been playing around with it. There are quite a few updates. Download, so you can download SiteLog, and right now we're supporting ASCII. In phase 2, we'll have full support for GeodesyML and JSON. So you can download, this is the most recent published version. If there's any modifications, you can also download the what's modified and waiting for publish. We've got an alert system. If you see anything here, you probably got an email asking for some kind of correction. These are manually generated by moderators. And so anyone who has access to, and they can be registered against an agency or a site or a person. So anyone who has access to them will see them. So earlier we talked about automation and APIs. And it's important to note that anything that you see that this user interface can do, you can actually do with a program. Because we have several APIs, and this is a graphical representation of our edit API. So if you're authenticated to the system, you can see this API and use it based on access controlling to the different sites. And this is a standard REST API. So it is a web server that'll handle standard HTTP verb actions like get, post, delete, and we will have documentation published for how to use it. So this well-structured API will make it so you could write a program to do anything that you can do through the user interface. So if you look at one of these, like the station scroll on the left-hand side was using this stations API to pull down these JSON structured data on stations. And we have a map API that this just publishes the SiteLog information in GeoJSON format, so you can easily render to different web mapping tools. And so new SLM, the SLM 2.0 has two main APIs. There's the edit API, which is access controlled. And then there's a public API, which is not access controlled, and it shows quite a bit less information, but it shows everything that should be public. So all of the published SiteLog data is exposed here. We have another stations endpoint, and in future, when we add some more richness to this, you will be able to ask SLM questions like, let's say, give me all sites that have a foundation of a certain type. So that's the level of searchability we're going for. Give me an example of the kinds of things you can do with access to these APIs. We do have this map view here, which uses our GeoJSON API just to render all of the stations to world map. And then a more richly searchable dynamic table view using our station API endpoint. So anything that you can do on this, you could write a Python program to also do. Let's see. So we will support uploading of site logs. And so instead of going through the edit interface, you will be able to just give us an ASCII file or a GeodesyML file, and we will run validation on it, and it'll be like you made the edit via the API. That is about it. So I guess I will take any questions if there are any.
All right. Well, it looks like Nacho has sent a message. Do we have a timeline?
Yeah, so I don't have an exact date for you, but we are going to be pushing this out into production as soon as we can. And we will put it up on that demo URL first and invite folks to play with it. It's very nearly feature complete with everything we need to replace the current SLM. So I would imagine in the next month or so. And once we've got it in operation, then we'll start tackling our phase 2 goals.
All right. And another question from Brian. If we install this on our end, how do our updates get pushed to the IGS Central Bureau?
So right now, it would be a separate install, so its own separate database. But since there are APIs on this thing, you could, and this is something, if there's huge demand for this kind of thing, I would be interested in knowing about it, because it certainly would be possible to support an automated backend link up. So like if you wanted to use your own instance of SLM to manage a collection of sites and then publish a subset of those to IGS, that is something that could be automated, since we do have these rich interfaces now. There's not an out-of-the-box solution to do that yet. If there's huge demand for it, it might be something that we should think about.
Okay. Any other questions? When you say a month or two, is that for GitHub or?
We should have, we'll have something up on GitHub sooner. And I guess it's we don't want to, we've got some testing and validation to run through before we replace it on the current system. So the only reason I'm hesitant to give a date is because I want to make sure it's ship shape before we swap it out.
Right.
Yeah, so once to extend on that, once we have a release candidate available that all the minor bugs and everything has been resolved, then we'll put it on the GitHub for users to download and just install and start using it and testing it for their field. So to answer Jose's question, if we're planning to leave the log file behind and move towards GML or JSON, I think ideally maybe we would want to move towards that direction, though it will take several times with the involvement from the infrastructure committee, with probably the governing board and also the analysis centers, just to ensure that everyone is ready, and in addition to all the other networks that are operating the stations too. So ideally, yes, because it's a format that was defined some 30 plus years ago. So, but before the move is done, a extensive information will be disseminated through IGS mail or the websites or through every means that we can go.
So there's a transition period there, because we have to support legacy data for a while, right? So our goal is the SLM will support everything until the old ASCII format really is no longer in use, and then we might just drop support for it. But you know, there are a lot of sites out there that have, you know, old data that's just going to take some time to bring up into the more strongly typed structures.
Right. Corinne asks, do you foresee manual validation of the SiteLog before making it publicly available?
So this is something that we've put flexibility into it, so you can configure it to say it requires a moderator to look at it before a normal user can publish it, or you can allow a normal user to publish anything that doesn't have a validation flag on it above a certain level. So the answer is it's really flexible, and that flexibility is both there to support folks who might want to use this who aren't IGS, but also so it's easy for IGS to kind of tweak it towards what's working over time. So that is a deployment time decision.
Okay, Pipta asks, is the IGS SINEX file directly generated by SLM 2.0, or is this done by some other software from the log files?
So we have the SLM, the current active one is the legacy 1.0, and we do have some scripts that directly connect to the database and get the data out from the database and generate the SINEX file.
Nacho says that IGS SINEX will be needed long-term in his opinion. And Peter says, yes, it is the source for our automated processing of metadata.
Yeah, in fact, I was with the talk that we were having at the infrastructure committee. It just came out that it seems there's quite a bit of dependency on the SINEX and also with some limitations to it. So I was talking with Markus to see if it would be worthwhile or beneficial to introduce a JSON format of the IGS SINEX, and that would eliminate the dependencies on that, on the number of characters, for example, and just to see, since it is a Python native and scripts or users can just easily render that information and process. So I'll probably reach out to some people to see if it's possible for their processes, or maybe to learn on some of their processes to see how this information is captured, and we can see if we can move on from that. But that'll be conversation down the pipeline later on. Any other questions? All right.
Okay. Robert, is there anything else that we should, oh, one more question. Can the SLM 2.0 handle additional fields that are not historically in SiteLogs?
That's a great question. The answer right now is no. But if that is desired, that would be quite easy to implement to handle arbitrary data. I mean, we could, yeah, I mean, there would be a number of ways to support that kind of thing. And it might be, we are going to support file attachments on these, like image attachments. So theoretically, you just upload another file and you can do it that way. But there are other ways, like we could store arbitrary JSON on a site too, that kind of thing, or even XML. So it's something we could support, but right now it does not. No. And since the open source framework this is built on, it takes great pains in its design to make it such that if you want to extend a site built using Django, you don't have to fork it typically. You just have to add a plugin to it. So everything's very easily overridable and extendable. So if someone had the desire to augment these site logs with their own sort of structured data, they could simply create a plugin and add it to the data model.
Right, and that's a great point to reiterate that we will be making this open source. So it is a resource for the entire IGS community, and we're really hoping that the entire community can benefit from this. And who knows what interesting plugins or other improvements our community members will come up with. All right, Robert, do we have anything else on the SLM?
That's it. Thank you, everybody.
All right, and thanks so much to Robert for leading this, and to Ashley for all of the user interface design, and to Brian for really making it sing. So I think that we can now move on to GeodesyML unless there are any other last minute questions. All right, Markus, the floor is yours.
Yeah, thanks a lot, Alison. And thanks, Robert and Brian, for the nice introduction to the new SLM. It's a great move forward indeed. So I just want to give you an update from the GeodesyML working group. So first of all, a bit of background and a bit of metadata history within the IGS. So you all know that the IGS has relied on the ASCII SiteLog since more than 20 years. And you might have been aware also that the maintenance of GNSS metadata using GeodesyML has been proposed a while ago now. So I think it was in 2015 as an initiative within the IGS Data Center Working Group. And back in the days, I think it was Fran Bowler and Nick Brown from Geoscience Australia who made that step forward. And efforts have been made to advertise the standard, but at the end, no final implementation on an IGS level could be implemented. So we reinvigorated the working group in July last year with members from Geoscience Australia, the Royal Observatory of Belgium, GNSS Science, UNAFCO, the IGS Central Bureau, GFZ, and since some weeks ago also from IRIS, so the seismology group. You learned yesterday that IRIS and UNAFCO merged together, so this is also a step forward for us to interlink with other domains. Why do we need an improved metadata standard? Geodetic services provide data for an increasingly diverse community, and in the past the user community was predominantly those from research and surveying authorities. But nowadays, the society has a high interest in reliable positioning information, and of course, new markets developed. And I just pulled up the OISPER market report from 2022, and you can see that there is a lot of revenue in different segments expected. Of course, in the consumer solution industry and road and automotive, but also in other segments like agriculture or infrastructure, aviation, or the rail industry. So what does the actual user need from us? The current standards don't serve the needs of new, also non-geodetic users. There's a need for a multi-domain standard to connect to other domains. In order to service these user demands, our geodetic data and associated metadata need to be standardized and fair. And fair means findable, accessible, interoperable, and reusable. And if you have joined the infrastructure committee session, there was a question on what do you think, how fair is our metadata and data? And I was quite surprised that the answer was relatively high, because in my opinion, we are far away from serving all the FAIR principles. We have an increase in volume and complexity of data, or the increase in volume and complexity of data means that we also need to create, transfer, and use data and metadata using a machine readable format. And users need to be able to query, access, and retrieve data without knowing how or where the information is stored. So just a quick introduction to GeodesyML. So GeodesyML is a new application schema of GML, so the geography markup language. It has been developed by staff from Australian and New Zealand government geodetic agencies with input from the former IGS data center working group. It describes how geodetic data and metadata can be described and transferred in an XML format. And it's a standard which makes data and metadata discoverable and interoperable, easily transferable via web services, and it's based on internationally recognized standards. So GML, the geography markup language, provides a rich set of primitive objects, such as geometry, coordinate reference systems, time, but it does not contain any detailed features to describe a GNSS or other geodetic site. So features like describing the antenna or receiver information is not included in GML. So GML application schema extends GML to meet the needs of a specific community of interests. For example, there's a format called SensorML, which is also an application schema of GML. And for more information, you can also refer to geodesyml.org. So here's an example of the old ASCII SiteLog format. We all know how it looks like. It's ASCII based, it's human readable, but there are a lot of issues with it. So there's no schema behind, and no schema also means that there are no rules. The format is not versioned in any way, which makes it also hard to provide updates to the format. It's not standardized, or not standardized on an international standard. It's very hard to pass. It's actually very painful to pass this format. And we also need the metadata in other formats like Synax, as you heard before. And since this format is called GeodesyML, it was also intended to extend this format to support SLR, VLBI, and DORIS, which have all similar site logs to the IGS ones. And this is just an example how the same site location information would look in GeodesyML. So you see that you have code lists available for the countries, for example, or for the tectonic plates, and also information for in which reference system the coordinates are listed. So now with the updates from the working group, so Geoscience Australia and ROB, they already use GeodesyML operationally. So you know from ROB, most of the European colleagues at least who are involved there, they developed the M3G. And you also see that there are 2 apps in implementation. So you saw the update from the SLM 2.0, which is written in Python. And GFZ also develops a new system that will replace the Zemisys system, which will be written in Laravel, which is a PHP framework with a REST API and with a React Material UI frontend. Yeah, both implementation phases were anticipated for July last year to July this year. We still need 2 or 3 months more, and you heard from SLM 2.0 they have the same kind of time frame, and both systems are planned to be open source. And we also, since this will be a big change also for the community who relied on the ASCII SiteLogs, we also want to make tools available to the community, to have an easy transition. And okay, so for GeodesyML, and I think that was also a question in the chat with new features and backward compatibility to the ASCII SiteLogs. Our plan is every new feature that will be addressed will be only addressed in GeodesyML and will not be available in the ASCII SiteLogs. And there are new features coming in GeodesyML. Some are features that accommodate the FAIR principles that were proposed by Karine and her group from the Royal Observatory of Belgium. So we will add license information and keywords. We will add network information with a code list. So you can say a station is part of the IGS, EPN, RPREF, etc. And you can also list information to which data center the station sends its data, also with a dedicated code list. We further want to move away from free text and create code lists, specifically for the areas to describe monuments and markers. Tectonic plates. There we will go forward with the Morville 56 plate tectonic model. We want to describe geological features. From my point of view, that was always one of the only fields where I can't really describe what kind of geological features our stations have. There was a request also that we should create code lists for receiver firmwares, because there's quite a variety sometimes in which way the same receiver firmware has a different kind of naming. And we want to do the same for meteorological sensors. Okay, so what's next? We want to define a standardized way to exchange metadata between different organizations. So between IGS and the M3G, for example, or IGS and Geoscience Australia's site manager. So that there are different ways how we can do it. You could either do it with a pull request, or you can push metadata from one or the other system. We also want to link other instruments and domains in a better way, including also persistent identifiers from different communities. Here an example from the seismological group. They have a metadata standard that is called Station XML, and they also have persistent identifiers for their stations. So if GNSS and a seismological station are collocated, then we could describe this also in GeodesyML and link to the seismological metadata. And we're currently checking the incorporation of SensorML to describe other sensors that are collocated. Here are the current members of our working group. And yeah, if you want to join, you can ping me. And I'm happy to answer any questions. And that's it from my side. Thanks.
All right. Thank you so much, Markus. There's been so much work going on, and it's nice to see people coming back together and reviving discussions about metadata. Do we have any questions or comments about this or any of our topics? All right, well, if anyone has any other lingering questions, they can be sure to either contact the speakers directly, or you can always feel free to send a message to the Central Bureau, and we'll be happy to direct your message to wherever it needs to go. Last call for questions or comments or any kind of other discussion. We do have a little bit of time left over. Yeah, thanks, Robert. Robert put the Central Bureau email in the chat in case anyone would like to further discussion. Karine, to come back to your remark that you were surprised about the God score of the fairness of IGS data. I think not everyone is aware what FAIR is about.
Yeah, I think I had the same impression. I can agree with that, Karine.
Yeah. All right. Yes, we might need to do some work on outreach and making sure people are aware of what FAIR actually means. It could be that a lot of people are familiar with it on a very high level, but drilling down into what that actually, how you actually prove that something is findable, interoperable. Yep. All right, the link for FAIR is in the chat in case anyone would like it. Thank you very much. Elizabeth, if you'd like to unmute yourself and actually talk, please feel free.
Hello all. I was just wondering if there is any other group that for IGS products are looking into modernize how metadata of those products are shared.
That's a good question. Markus?
I'm not aware. I think this question went out to the others who are in the room here.
Yeah, it was for the others. Thanks.
Yeah, I haven't seen any forward coming from the other agencies to start participating in it, but hopefully with today's talk, and once we start with our second phase of interoperability, we will have some participating agents that we can start moving towards that direction.
All right. Okay, so if there's nothing else, any other feedback right now, I'd like to very much so thank everyone who presented today. Tim, Robert, Brian, Markus. It was a great variety of topics and really a good conversation. And we're very much so looking forward to next steps. So with that, I think we can end a tiny bit early in this session. So thank you all and have a good day, evening, or morning, wherever you may be.